Alright, so we're going to go over the next set of questions, starting with question 16. Alright, the measure of what the expression of the equivalent. We have to do equivalent expressions here. It's essentially just multiplying polynomials. We went over that in the first video with the quantitative reasoning, but essentially this is just a distributive property. We do it twice. So I have x minus 2 times x plus 3. So how I would do this is, first thing I would do is pretend like this negative 2 wasn't there and distribute this x to this x, and I'd go x squared, right, because x times x, and then I have x times lots of 3, x plus 3x, alright? Then, and once you get used to this, you don't have to cross things out, right? You have this times this, this times this. You have negative 2 times x, which is minus 2x, and minus 6, x squared minus x minus 6 is your final answer. X squared minus x minus 6. So that's C. Easy enough there. Okay. Next is question 17. The slope of the line. Slope is just rise over run, and you just have to determine whether it's positive or negative. So the first thing you need to realize is this is a negative slope. The way I like to remember that is to think about the letter A. If I'm going up like that, that's positive. If I'm going down like this, that's negative. If it's right in the middle, like that, that's 0. So this is positive, this is negative, this is 0. And then I like to think about this. If it's a straight up in line, it's like A1. So this is by itself, all alone, and it's undefined if it's just going straight up and down. Alright, but let's not worry about that for right now. We just need to determine this specific line. I have that I have here. This is going to be a negative slope. So it's and then I determine 2 cross sections. One cross section here, one cross section here. If I can get more, but all I need to do is check the cross section. So then I see I went up 2. So rise is 2, run is 1. It's negative. Now be very, very, very careful, because I also have to check the scale. What is this going by? This is going by 1s, right? If it was going by 5s, I'd have to multiply the 2 by 5. If it was going by 10s, I'd have to multiply by 10. So the scale is just 1, and the scale for to the left to right is also 1. So that's negative 2 over 1, so which is just negative 2. Alright. Now we have number 18. This is known as, we're going to do a problem that has to do with it's known as the distance formula. Distance formula is just a variation of the Pythagorean theorem. So essentially this is asking you about 2 points on a graph and how far they are from each other, right? Point 1, 8 is on a circle with a center of negative 2, 4. What is the radius of the circle? So essentially you have a graph, and they're asking you from the center to this part is what's this distance, and it's on a graph. So anytime you're asked about distance on a graph, we're going to use what's known as the distance of points on a graph. We're going to use what's known as the distance formula, and that is, it's essentially the Pythagorean theorem. Okay, let me try and erase everything here. It's the square root of of x2, right, and I'll get to what x2 means in a second, minus x1 close parentheses squared plus y2 minus y1 close parentheses squared. Now what x1 and x2 mean, right, is this. This is x1, this is x2. This is y1, this is y2. Okay? That's pretty simple. So now what I do is just plug in my numbers. The square root of, well, x2 is negative 2 minus 1 squared plus y2 is 4 minus 8 squared. This is going to give me, it's negative 2 minus 1 is negative 3 squared plus, this is going to be negative 4 squared. Take that, go here, that's going to be the square root of 9, because negative 3 squared, negative times a negative is a positive, 9 plus negative 4 squared is 16, negative times a negative is positive, right? I take that, I get the square root of 25 equals 5, right? It's really equal to 5 or negative 5, but distance can't be negative, so you have 5. So we have 5 grid units, which was C. Number 18 was C. Number 19. Terry is planning a survey to try to determine the average number of hours at her school spent watching TV. Which sample of students will give her the most reliable information about students in her school? Alright, so sorry I saw that cut off, so just one more time. She's planning a survey to determine the average number of hours at her school watching TV. Which sample will give her the most reliable information about students in her school? So we have let's see. Well, we have to be very careful with this, right? So if we're trying to determine the whole school, like, we have to try to be as random as possible, right? We have to make sure we have a good sample size. It's a whole different group of people, all right? So now, first, if you're just serving your friends, that's not going to work, because your friends might be like-minded, they might be really into studying or really into watching TV, so that's not going to work. A random sample of all the students in the school. That sounds very appealing, right? Just randomly choosing people in the school, all right? Now, C might look appealing, but we want to see what we're dealing with. All the people that show up to watch a football game. Well, it might only be certain types of people who show up to watch a football game. All right, what if everybody who's not at the football game is watching TV? What if, right, and the reason they didn't come is because of TV. So not everybody goes to the football game, whereas everybody goes to school. So it's not C, random sample, and then D, a random sample of students in the library before school. Well, it's definitely not this, because only certain types of kids are going to be at a library before school. They might watch TV, they might not watch a lot of TV, right? Whereas B is the most random sample of everyone. Okay. Number 20. The measure of 3 of the angles of the quadrilateral are given in the diagram. What is the measure of the 4th angle? Now, the first thing you need to know is the sum of the interior angles are all angles of a quadrilateral. So if you're not sure, right, some people know that's 360, some people don't. But if you're not sure how many degrees are in a shape, all you need to do is the number of sides minus 2 times 180. All right, and that will work with any shape. A pentagon, if it's 5 sides, 6 sides, you can even figure out how many degrees are in a 20-sided figure. Just do 20 minus 2 times 180. So there's 4 sides minus 2 times 180. So 2 times 180 equals 360. So I know there's 360 degrees in a quadrilateral. All right, and I'm having missing sides, so I know that 110 plus 75 plus 130 plus x is equal to 360. That's what I do know. Okay, so now what I'm going to do is I'm going to add all of this together and solve for x. So if I have 110 plus 75 plus 130, if I add this together, I think I should get 315. Check my math. Yeah, 315 plus x equals 360 minus 315 from both sides. Alright, and I should get 45. X is equal to 45, and that is number 20, right? Just 45 degrees. Alright, now number 21. 21 is a little bit more challenging. I'm debating whether I want to go over it just because I'm dealing with combinations and permutations. It's a 6-member debate team plans to send 3 of its members to a conference. How many possible members from a 6-member team? Let's skip this one for now and come back to 21. I will definitely go over it. It's just a little bit more time consuming because I have to go over 2 concepts rather than just one, so we'll come back to 21. Alright, maybe towards the end of the video or in the next video. Alright, number 22. The grid shows 3 vertices of a parallelogram. Alright, which could be the coordinates of the 4th vertex of the parallelogram? So this would be, this one is, you just plug in your 4 numbers and show which one gets you a parallelogram. So if I do that, -3, 5, clearly not a parallelogram, so it's not A. -2, 0. Kind of looks like a parallelogram, but not quite there. So not B. 0, 1. That's definitely not a parallelogram. It's more of a trapezoid. And 7, 2. Ah, okay. Well, now this is what a parallelogram looks like. Exactly. Boom, boom. And I know I drew it really poorly, but that's a parallelogram, so your answer is D. Number 23. Number 23 should not have been a problem because I know you guys have spent quite a bit of time on absolute values and inequalities, but we can go over it really quickly. So if I have 4x minus 7 is greater than or equal to 9, the first step, and that's the absolute value, the first step is to see, well, is the absolute value isolated? And it is, right? There's no other thing that I have to isolate It's not like 5 plus the absolute value or 3 times the absolute value. Everything is inside the absolute value sign. So now I can split it into, and the second thing is I have to check if it's equal or greater than or equal to a positive number, which it is, right? Because otherwise I'm not able to do anything. So now 4x minus 7 is greater than or equal to 9. And then I also have 4x minus 7. And some of you will remember this. I need to flip this sign is less than or equal to negative 9. And then I add 7 to both sides. 16. 4x is greater than or equal to 16 divided by 4 divided by 4. X is greater than or equal to 4. And then I have plus 7 plus 7. 4x is less than or equal to, now I'm negative 1/2, negative 2, and I'm going to end up with negative 1/2, but let's just double check. Divide by 4, divide by 4, x is less than or equal to negative 1/2. Alright, so in this case I have x is less than or equal to negative 1/2, or x is greater than or equal to 4. This is going to be a disjunction. Alright, and so your answer is D. Alright, which of the following could not result from the difference of two irrational numbers? Okay, this one, even if you don't know the answer, right, you can go through process of elimination. Suppose you don't know all of the terms, but you know what an irrational number is, you know what an integer is, right? It's the only term that people would sometimes get a little lost on is a complex number. Alright, the other ones I know you've seen at some point. So let's just see if we can deal with those three first, and then if we can, we're good. If not, then we'll have to use process of elimination, and you might have to take a guess or see how it is. But let's go through process of elimination here. All right, the result of two irrational numbers. Well, let's think of an irrational number. Okay, this irrational number is the square root of any number that doesn't come out evenly. So square root of 7, and let's think of another one. Pi, that's another one, or the square root of 15. All right, now let's see. Is there any situation where I could get the difference of two irrational numbers and it turns out to be an integer? Now, here's the key thing. Did they ever say that it couldn't be the same number? Right? They said two irrational numbers. They could have been two of the same numbers. What about the square root of 7 minus the square root of 7? That's just equal to 0. So it can be an integer. Now, a rational number. Can I ever get a rational number from the difference of two irrational numbers? Of course. 0 is not only an integer, but it's also a rational number. So B is also gone. Oh, suppose you don't know what a complex number is. Alright, but essentially, if you need to know, we're talking about what complex numbers is when you have like a real part, because we haven't really gone into imaginary numbers, so it wouldn't make much sense. So I don't want to confuse you too much there, because they have like real and imaginary parts. But let's just hold off on that. But for D, are you able to get an irrational number? Well, of course you are. If I take the square root of 15 minus the square root of 7, that's going to be, I don't know what it is, but it's going to be an irrational number. It's going to go on forever without any sort of pattern, because they're two numbers that don't have a pattern in the first place. So in that case, it has to be a complex number. And it makes sense because complex numbers have imaginary parts as well. So that's why that kind of works. All right, let's stop there for this one. We got through a few problems. We'll do the rest in next set.